Welcome! Today I'll show you how to deploy an ASP.NET Core 3.0 Web API on Azure Kubernetes Service, also known as AKS. You will learn how to create a container registry and an AKS cluster, how to push your Web API container to a container registry, how to generate Kubernetes YAML files to describe your deployment and service using Visual Studio Code, and how to deploy your Web API container to AKS. To follow this video step by step, you will need a few things. First, the Hello ASP.NET Core Docker image created in my previous video, containerizing an ASP.NET Core 3.0 Web API. If you had not seen it already, please go through the steps on that one and then come back. Second, Docker, which we will use to manage Docker images in the dev box and to push a Web API image to the container registry. Third, the Azure CLI, which is needed to be able to manage Azure resources like container registries and Kubernetes clusters. Next, Visual Studio Code, which we will use to generate and edit the required Kubernetes files. You could of course use any other code editor that works best for you, but you might miss a code generation piece. And finally, Postman, which is handy to query our web API once deployed on Kubernetes. Again, you are welcome to use a browser instead for this if you prefer, or any other tool that better suits your needs. Since we will be deploying our container to an Azure Kubernetes service, we will need an Azure subscription. If you don't have one already, you can get a free one by going to azure.microsoft.com/free. The free subscription will give you all you need to try out AKS and any other Azure resources. Once you have an Azure subscription, you can go to the Azure Management Portal at portal.azure.com, and here is where you manage all your Azure resources. And the one resource that we need to get started is a container registry, which is basically storage in the cloud for your Docker images. We need to publish our Hello ASP.NET Core image to a container registry so that later our AKS cluster can pull it from there. So let's go ahead and create a resource. Let's say container registry, create, and you can really use any name for this registry. I'll just use my name and O1. You will pick your subscription here, and then you have to either select or create a resource group. The resource group is just a logical grouping of resources in Azure. That's very useful for creating a bunch of resources at once or deleting all of them also at once. In this case, we'll just assign the same name, create a brand new one just for the case of this Azure Container Registry. And finally, we'll pick an SKU here, and the basic SKU should be good enough for this video. Just click create, and this will get the deployment of this container registry started. While that happens, let's switch to Visual Studio Code, where we have already opened the folder where we have all these files that we've been working since the previous video. And what we're going to do here is first to log into that Azure subscription. So to do that, we'll use the Azure CLI, which is installed already, and we'll do AC login. This is going to open a browser window, prompting us to authenticate to Azure with the right account, and it's logged in. So now let's close this tab, come back to Visual Studio Code, and now we are logged in, and we will now just want to make sure that we have selected the right subscription among the bunch of ones that we may have available there. So let's do AC account show. Let's see what subscription comes back. We get BSF Essentials. So this is the one that I actually created as a free trial for this video, so we are in a good place. Now, what we want to do now is to create what we call an Azure Service Principal. The service principal is nothing more than an identity for an app or a service that in this case we will use to configure the Kubernetes cluster so that the cluster can authenticate and pull the images from the container registry. And to create this service principal, what we can do is use the ACAD sp create for RBAC command. And then we'll do skip assignment and then hit enter. So this is going to create a service principal, and it should come back with all the details about the service principal just created. The most interesting details about the service principal are the AppId and the password that you can see here. So both them, let's actually copy them to some location so that we have them handy when we are going to create the AKS cluster. All right. So now we have done this, let's go back to the portal and let's see, deployment succeeded. The container registry is created. So let's go to that resource. What we want to do now is grant access to this service principal that we just created into this container registry. Okay, so that anybody that authenticates as that service principal can just pull the images that we have here. So let's scroll right and add a role assignment. The role that we want here is the ACR pool role. There's a bunch of other roles you could pick here, like being owner, the most powerful one. But really, the only thing that this identity is going to need is just to be able to pull images from here. So kind of a good security practice to only grant the right role or permissions that are needed in each case. So now we need to pick that service principal. So we will use the AppId for that. Here it is. Save. So now, if we go to role assignments, we should be able to see. Let's refresh. There it is. Our service principal now has ACR pool permissions on this container registry. Now it is time to create the Kubernetes service. So to do that, we'll go to create a resource. Let's do Azure Kubernetes Service. Create. Okay. And same as before, we'll need to pick a resource group. In this case, we'll use the same resource group that we had created earlier. So let's open up this. Okay. We'll need a cluster name. I'll just give it that same name. You could use a bunch of different names in there also. I think that's the other thing that we need here is to pick a size or an SKU for the nodes that we're going to use in this cluster. So there's a bunch of size available here, and if you click on change size, you're going to get a list of all the ones that are available for your subscription and for the location that you have selected. Since this is just like us trying to learn how this works, I will encourage you to go for the cheapest one available, and in that case, that's going to be the B2S SKU. So in fact, let's scroll right. Yeah, so that's the cheapest one available. So you just go for that, and that should work just fine. And for node count, we'll just do 1, since again, this is just us trying to learn things. And let's go to next. We'll not pick anything in this section. Let's go to authentication. Now here is a very important part where we need to configure the service principal that this Kubernetes cluster is going to use. So click here, select use existing, and we go back to that combo of AppId, and in this case we also need the password. Okay, and if we go to next networking, we're not going to pick anything here. Or monitoring, we will not be enabling monitoring for this video, just for the sake of speeding things up. And that being said, the monitoring that's available here is really good. So for your production clusters, you totally want to enable this. So let's actually go to review and create now. Let it run the final validation. And then we should be able to go ahead and create the cluster. Click create. Okay, so while that happens, and this is actually going to take a few minutes, let's switch back to VS Code. And this time, let's actually start interacting with the container registry. So it is time to push the image that we have locally so far, and we need to send it to the cloud, to the container registry. So first thing we'll have to do is to log in to the container registry that we created. So to do that, we will do ACR login -name, and now we need the name of that container registry. So if we go back to the portal for a moment, let's go home, and let's go to, here's a container registry that we created before. And you can see the login server name and the container registry. The name that we are going to use is the name of the container registry right there, Julio01. So back to VS Code, I'll use that name. So this is going to authenticate our Docker engine that we have in the box against that container registry. Login succeeded. So now we're able to start interacting with that ACR. So let's actually browse the images that we have in the box right now to confirm that we have the image that we want to work with. So let's do this. And here it is, Hello ASP.NET Core v1. So this is the one that we want to send to ACR. So, but before we can do that, we need to retag this image with a repository name and tag that actually makes sense for that container registry. So to do that, we're going to do docker tag. The current image name is Hello ASP.NET Core v1. And what we want to do is retag it as the name of the login server. Let's go back to portal. Here's the login server, copy. Okay, login server / repository name. So repository name is going to be Hello ASP.NET Core, and we'll use the same tag. Hit enter, and let's do Docker images again. So this time you'll see that we have a new, what seems like a new image here with the ACR login name and the repository and the tag. And just notice that this new tag is just really another pointer or another kind of an alias of the same Docker image. If you see the image ID, it's exactly the same image that we had before. But we need it in this format to be able to push it into the container registry. So now that we have this, we can go ahead and do Docker push. And then we'll do our new image name, v1. Okay, so this go ahead and is going to start uploading all the layers that correspond to our Docker image, and that includes the ASP.NET Core 3.0 runtime, plus all the layers that involve our application. So all the files, all the binaries, and anything else that is involved in our image. So the very first time that you do this, it will take a while, especially because of the ASP.NET Core runtime image. Which at the same time is based on some Linux image, so a bunch of things to upload. But the next time that you upload this, it will only upload any new layers that you have created. All right, so it is done now. And if we go back to the Azure portal and we now go to repositories for that container registry, we can see that Hello ASP.NET Core is right there in tag v1. So we have the container image ready where it should be. So back to VS Code, it is time to declare how we want to deploy our image into the Kubernetes cluster. So to do that, what we're going to do is take advantage of the Kubernetes extension for VS Code so that it can generate the files that we need for us. So if you have not done it already, go to the extension hub. You can type Kubernetes here, and it will be the first option here. So go ahead and install this extension, and it includes a bunch of nice things. And the one that we're going to use here is the ability to generate YAML files for us. Now, one thing about this extension is that at the time of this recording this video, there was a bit of a bug in a dependent extension. Is called the YAML extension, which makes it so that Kubernetes extension is not able to actually generate the files. So to make sure that you can do this, go to find the YAML extension here and make sure that you're working with version 0.4.1. And if you don't have that version, just click on the gear icon, install another version, and pick version 0.4.1. That's all it is. Close it. So now let's go back to the files and add a brand new file. Let's see. Brand new file, let's call it deployment YAML. Okay, and let's actually close the terminal for a while. And let's just type deploy, and as you can see, pop-up menu will show up right here, Kubernetes deployment. We just have to click on it, and right away it will generate an initial skeleton for our deployment file. So the first thing that we need to do here is to assign a name to this deployment, and that we can set in the metadata name property here. So we will call this deployment hello ASP.NET Core deployment, right? That's how we identify this deployment in Kubernetes. Now, then the next thing that we're going to do is to set a name, uh, set a label for the pods that are going to be created by this deployment. Now, a pod is nothing more than a group of one or more containers that share storage and or network, and some sort of specification on how to run the containers. So the label that we're going to assign to our pods is going to be hello ASP.NET Core pod. Okay, and now what we also have to do is to specify how the deployment is going to select the pods that it's going to work with. So usually what you do is you take the name of the pod, and that's going to be the match label here that we're going to use in the selector. Okay, so this means that this deployment is going to work with all the pods that have the Hello ASP.NET Core pod label. Next, we have to specify, let's look at the container section. We have to specify first a name, a way to identify this container, this Hello ASP.NET Core container. So we're going to name it Hello ASP.NET Core container. And then the interesting part here is the image that we're going to use. This image should match exactly the image that we have deployed to the container registry. So if we go back to container registry, the name that we're looking for is the name of the login server, okay, which I just copied, and then slash repository name, in this case hello ASP.NET Core, and the tag. So the tag we're going to use is v1. Okay, so that's the image that needs to be deployed in these Hello ASP.NET Core pods. Then we have a section for resource limits. So these are the limits that will be set on these containers, the Hello ASP.NET Core containers, so that they don't try to go beyond those limits and reduce the amount of resources available for any other containers running in the node. So what we're saying here is that we're going to set a limit of 128 megabytes, which is very similar to 128 megabytes. And we're going to set 500 milli CPU on the containers, which is equivalent to like 1/2 CPU, pretty much. So 128 megabytes and half CPU is the maximum that these containers will be able to use. And finally, we have to specify the port where the container is going to be listening to. So that port, as we did when we worked on just on the container, would be port 80. Now, just doing this will allow us to create the pod in Kubernetes, but that's not going to be enough for anybody to be able to query our web API from the outside. To enable this kind of a window into the running containers, the running pods in the cluster, we have to define what we call as a service. So let's add another file here. Let's call it service. Actually, let's call it service.yaml. We're going to type here service, select Kubernetes service, and there it is. Okay, so a service is just a logical representation, a logical object that allows for the interaction between different objects in Kubernetes, and also potentially allows external communication with the bots. So first thing we're going to do here is to assign a name to this service. So let's call it Hello ASP.NET Core Service. And the important part here is a selector. So just as we did before, we need to specify which are going to be the pods that are going to be interacting or reachable by this service. So those pods are going to be, just as we said before, the Hello ASP.NET Core pod. That's a label that all our pods use, and that's a label that we have to use as a selector here. Then the port is going to be the port that external callers can use to reach out to those pods. So our port is going to be, in this case, 8080, and the target port should be the port that we defined when we expose the port over here. Port 80, that's going to be our target port. One last piece is to define the type of service that we're going to deploy here, which is, let's see, type load balancer. So a load balancer is the kind of service that actually acquires a public IP from the cloud hosting provider, and it assigns that IP to the service so that external callers can use that IP to communicate with the service and with the pods that are behind the service. So now we have these files ready. So it's time to actually perform the deployment in Kubernetes. So first thing we're going to do is verify if the cluster is now actually deployed. It took a while, but let's see, indeed, deployment succeeded. So let's go to that Kubernetes cluster. So here it is, our Julio 1 Kubernetes cluster. So what we have to do now is go back to the Azure CLI and now open our terminal, new terminal. And we're going to connect to the cluster. So the way that you connect to the cluster is via the AKS get credentials command. You have to specify the resource group where the cluster lives. In our case, the resource group is Julio 01. And the name of the cluster, which is also Julio 01. Okay, hit enter. And what this does is it downloads the secret to be able to connect to the cluster into your box, and it stores it into this config file in this location. Now, if we are connected, well, an easy way to tell if we are properly connected is to use the kubectl tool, which, by the way, should be installed with your Docker desktop installation. If this tool is not being found, you should just go ahead and close VS Code or close your terminal or your command line tool and open it again, because it should be in the path of your computer, so it should be available right away. Now we will do kubectl get nodes. And this, as you can see, it's listing the one node that we have available in AKS. We have nodes. So it's time to apply our deployment. So let's do kubectl apply -f for file. And first, let's go with the deployment YAML. Okay, so it says deployment created. So let's see kubectl get deployments. And there it is. We have our Hello ASP.NET Core deployment right there. Still waiting to be ready. And what we can also do is see the pods of what created here. So kubectl get pods. Okay, you can see the container is creating. So it may take a few minutes depending on the size of the container image that we published into the container registry. So let's try it again. All right. So the container is now up and running. This ready means that 1 out of 1 container is running. So this is good. Now let's also deploy the service. So kubectl apply -f service YAML. Okay, so let's do kubectl get services. Here it is. So now we have a Hello ASP.NET Core service. Which is the type load balancer, and you can see that it does have a cluster IP. So this is what we call the internal IP that resources within the cluster can use to communicate to each other. But the one that we are waiting for is the external IP that can be used to interact with the cluster from the outside. So that will take can take a few seconds or a few minutes to pop up, because now Kubernetes is talking back, in this case to Azure, to request the creation of a public IP and the assignment of that IP to the cluster. So let's try it again. All right, so now we have an external IP, which we're going to copy. At this point, we should be able to go ahead and query our web API now running in AKS. So to do that, let's switch into Postman, and then create a new request here. So we're going to do HTTP, the external IP, the port that we're exposing, as defined in the service YAML file, and our actual API, which is weather forecast. So hit send, and there it is. You can see the results of our weather API right there. So the Kubernetes cluster has succeeded. The container deployed successfully, and the web API is up and running in Kubernetes. If this video was useful, please consider hitting the like button. Don't forget to hit subscribe and the notification bell to know right away when I publish new videos. Also, please leave me a comment below with any thoughts about this video. Thanks for watching. See you next time.